Greetings, chemists. In this video, we will be discussing the topic of concentration and different ways that we can measure and calculate the concentration of a solution. So to review, in any solution, you have a solvent and you have some solute, which is the stuff that you dissolve into the solvent, and all together they make a solution. The solution is the combination of both. When we get to the idea of concentration, I can kind of illustrate it here. Let's put two solutions side by side, and let's suppose these are the same type of solution. So let's picture that this is like a lemonade solution, okay? And when I go to make the lemonade on the left, even though I have the same amount of water, let's suppose that this has a certain amount of lemonade particles. Now, you wouldn't see the lemonade particles, you would taste them, but they would be in there, invisible or mixed in. You would see, I guess, a yellow color. And let's suppose that I have the lemonade solution on the right, looks like this. If I were to taste the one on the right, it would taste much more strong than the one on the left. We would say this is more concentrated, and we would say that this is less concentrated. Okay? Well, that's a qualitative observation. It doesn't involve any numbers. But what we're talking about is that the concentration is about sort of the ratio between the solute particles and the solvent particles. So right now what we see is that if the two solutions have the same amount of volume, the one with more particles is more concentrated. We could do it differently. What if I drew this container versus this container? And I do like that, and I do like that. Now, these two containers contain the same amount of solute particles. There's 5 in each case, but the container on the right is basically about twice the volume. This would be not as strong a lemonade solution as this solution would be. So this would be more concentrated. And this would be less concentrated. So it's not about the actual amount. It's not about who has less volume, right? We saw in here, we have the same amount of volume, but one can still be more concentrated than the other. It's not about the actual physical amount of particles. This one can have the same as this and still be less concentrated. It's about the ratio. And so to define concentration for anything, concentration is the ratio. It's the ratio of solute to solvent. Or sometimes, I'll say there's another way to write it. Sometimes you'll see it's the ratio of solute to solution. And it depends on which type you're using. So let's talk about one way that people measure concentration, which is percent concentration. Percent concentration may be familiar to you. So, for instance, anybody who uses contact lenses probably uses a 0.5% saline solution to store their contact lenses in. And it's also a useful eye drop if you have to put it into your eyes. Okay. This is because your body is also about a 0.5% saline solution on average. Okay, what does that mean? Well, that means that for every 100 grams of water, or of solution, I guess, that would be a 0.5 gram salt. So if I wanted to make a 0.5% saline solution, I could put 0.5 grams of salt into a beaker, if that was 0.5 grams, whatever that is, and then I would find 100 grams, or I would fill it up until the total solution weighed 100 grams. I would fill it up with water, all right, and that would be a 0.5% saline solution. Now, how am I doing that? We have a formula we can write. The formula for a percent is, at least for a solution, would be the grams of solute divided by the grams of solution. And then because it's percent means that for every 100, so we multiply it by 100. So a sample question might be, you go out to make your lemonade solution, and you take 30 grams of lemonade powder, and you dump it into 100 grams. Let's say you make 200. Let's say you dump it into 200 grams of water. And we might ask, what percent lemonade have you made? What percent solution is made from 30 grams of lemonade into 200 grams of water? There, we made it an actual question. Okay, I'm going to use this calculation. The percent would be equal to the grams of solute, which is 30 grams of lemonade, divided by the grams of solution. Now be careful, it's not 200 grams of solution, it was 200 grams of water. And if I combine that all in the same container, it would be a solution of 200 grams and the 30 grams of lemonade. So altogether, that's 230 grams of solution. The solution is everybody together. Okay? Times, it's a percent, so I have to multiply by 100. And what we would see, now I do need my calculator for this one. That would be 30 times 100 divide by 230. And my calculator says that is 13%. So a 13% lemonade solution. Now, I don't know if that's actually the recipe for lemonade. Maybe that's too strong or too weak. You could try it out at home and see how that comes. Okay, that's one way to calculate concentration. The other way, the other main way we're going to do in our class is using what we call, moles, using moles of solute, right? So for chemists, we like to measure out molecules or moles. So we could take a concentration which was equal to the moles of solute, and we could divide it by the liters of solution. This is very commonly done. When we do it this way, the type of concentration we're calculating is called the molarity. So let's do our lemonade question again, only this time let's use moles. So let's suppose that when I go to make my lemonade, I take, let's say I take 2 moles of lemonade, and I add it into 3 liters of water. I'm going to make a big batch of lemonade. Okay? What would be my concentration, assuming I'm doing molarity? Molarity is equal to moles over liters, and in this case, that would be 2 moles of lemonade divided by 3 liters of solution. Now, in this case, I'm probably, when I make this, if I would really want to make this 3 molar, or whatever this is, we haven't calculated yet. If I really want to do that, what I do is I dump the lemonade powder in first, and I have like the 3 liter line, and I fill the water up till it's right at 3 liters. That way I am getting 3 liters of solution, not just 3 liters of water, okay? And then I'll get 2 over 3 is, what, 2/3 is 0.6, 0.67. And the unit for molarity is capital M. We'll say it's a 0.67 molar solution. Okay, we call it molar is the unit. Okay, that's the molarity. And this is useful for us because very often in chemistry, we're counting up particles. We're trying to see how many particles there are in the solution, and moles is a way to count up particles. Okay, and it goes with all of our balanced chemical equations and such. Okay, so those are your two main tools we're going to be used to calculate the concentration of our solutions.